A Boeing 737-700 is climbing through 32,000 feet when suddenly a loud bang is heard. The aircraft rolls violently over to the left and panic erupts as the pilots are struggling to control their aircraft and the cabin is depressurized. When the dust settles, the cabin crew looks down through the cabin and realizes to their horror that one of their passengers had been pulled halfway out through a window. But this is far from the only problem they face at this point. Stay tuned. A huge thank you to Skillshare for sponsoring this video. The story of Southwest Airlines Flight 1380, it's a very fascinating one, but also quite complex. So what we're going to start with is talk a little bit about the 737-700 and the newly fitted CFM56/7 Bravo engines. The Boeing 737-700 is part of the next generation in the 737 family, and it is built essentially on the basis on the 737-300. The improvements that came in the next generation family essentially was a much more efficient wing, but also a brand new set of CFM56 engines made from General Electric in the United States and Snecma in France. Part of the improvements that came with these new engines was that they reduced the number of fan blades. In the old engines that was used on the 300, there were 44 fan blades, and in the new CFM56 engines, there was only 22 wider fan blades. These fan blades were made from a very strong titanium alloy, and because of the strength of them, they don't have what we call a finite service life. Instead, they are removed and inspected for fatigue cracking at regular intervals. The way that these fan blades are connected to the fan disc is the center part of the engine, is they have individual slots, and the lowest part of this fan blade is called a dovetail. That's what fits into these slots before they are secured into place. The next thing I want to explain is how these fan blades, which are quite heavy actually and spin at a really high speed, which means that they have a lot of kinetic energy in them, are protected from the rest of the aircraft. Around the spinning fan is something that we call a containment ring. This containment ring is made out of Kevlar and other really strong materials, and it is designed to withstand a fan blade out event, an FBO event. The way that we know that it can actually take this is that during the certification of the engines, they do something called an FBO test, a fan blade out test. Now this test is exactly what it sounds like. It means that a fully functioning engine is being put into a test bed. It is revved up to close to maximum capacity, and then one of these fan blades are rigged to be released. When it's released, it is then being tracked and monitored to make sure that the engine as a whole can sustain whatever damage that comes from it. And the idea is that the containment ring is supposed to take up most of the energy, and then the forward part of the engine, which is generally the cowling, we're going to get to that in a second, can withstand it and will not depart from the engine, right, and cause other damages. When the new CFM56 engine for the NG fleet was being developed, it had to go through all of the required certification testing. And when it came to the FBO test, there was a couple of assumptions being made. And one of them was that it wouldn't matter at what point the fan blade would be released. So the engine manufacturers chose to have it released at a 12 o'clock position, right, when the fan blade was straight up. The engine manufacturers had calculated that part of the fan from the fan blade out event could travel forward outside of the containment ring. And when they had been calculating this and running computer models, they thought that it's probably going to move forward at a spiral shape, but the helix angle of that spiral shape should be about 15 degrees. But when they ran that test, it turned out that indeed part of the fan blade did travel forward, but at a much bigger helix angle, closer to 26 degrees. The piece of the fan blade had much greater kinetic energy when it came outside of the containment ring into what we call the D-Duct Assembly, which is forward of the containment ring, and that caused a lot of damage. And because of that, the engine manufacturers had to go back to the drawing board, they had to recalculate everything, and they had to redesign both part of the containment ring and also the forward part of the D-Duct Assembly of the engine to make sure that it would be able to take it. And when they ran the test again, indeed, there was still a little bit of damage in the D-Duct Assembly, but the whole unit was still working. So when you're boarding a 737 and you look out to the engine, you'll see the big fan and the spinner in the middle. That's the one that has the spiral on it. But forward of that, a kind of barrel-shaped structure. And that's the D-Duct Assembly. It consists of an inner and an outer barrel, and then you have the aerodynamic lip in the front of the engine. And on the outside is an aerodynamic fairing referred to as the engine cowling. The engine cowling is divided into two pieces, and it has a hinge at the top, and then you have latches at the bottom. So if engineering, for example, wants to get access to the engine, they can open up those latches and kind of open the engine cowling, like two wings on the side. And those cowling pieces is going to become really important in the story. On the 17th of April 2018, Southwest Airlines Flight 1380 was a standard domestic passenger flight that was scheduled to fly from New York LaGuardia Airport in the United States over towards Dallas Love Airfield. This was the second scheduled flight for the involved crew of the day. The flight was completely fully booked with 144 passengers on board and 5 crew members. In charge of the flight was a 56-year-old female captain. She had been with Southwest Airlines for 24 years when the accident happened, and she had previous experience flying the A7 and the F-18 for the US Navy. She had 11,715 hours of total time and 10,513 in the Boeing 737. The first officer, who was going to be pilot flying for the flight, was also very experienced. He's a 44-year-old male with previous experience in the US Air Force, flying the T-37s, the T-1s and the E-3s, airborne warning and control systems. He had 9,508 hours of total time and 6,927 on the Boeing 737. So this is a very, very experienced crew we're looking at. The cabin crew, who are also going to play a really important part in this accident, had been with Southwest Airlines for 6.5, 4 and 2 years respectively. The aircraft that the crew is flying is about 18 years old at the time of the accident, and there was no known technical malfunctions on it when they took off from LaGuardia. The crew prepared for the flight just as normal. The weather was expected to be good both in LaGuardia and en route, and also in Dallas. And at time 10:43, they took off from LaGuardia Airport and started their climb towards Dallas. The climb up was completely normal, and at time 10:57 the crew received their clearance to climb to their cruising altitude of 38,000 feet from air traffic control. But as the aircraft passed to flight level 320, that's 32,000 feet, something happened in the number 1 engine on the left-hand side. In the dovetail part of fan blade number 13, a small fatigue crack had been developing over the last few years. The fan blade had been checked regularly during those years, but the type of check that was being used had not been able to detect this small crack. This crack had now developed far enough for the entire base of the fan blade to fail and detach from the fan disc. It did so in the 6 o'clock position, so facing straight down. And it impacted the containment ring, just as it was designed to do, and then part of this fan blade started moving forward. But when it impacted the containment ring and also the forward part of the D-Duct assembly, it created a shock wave. And this shock wave cracked the attachment ring that held part of the D-Duct assembly in place. It also caused extensive cracking in the latches that was holding the engine cowling in place. That caused the latches to fail, which made the cowling open, and because of the air loads, rip off the front of the engine. As this happened, the right part of the engine cowling, that's the inboard part, flew up over the wing and impacted the side of the aircraft next to row 14. When it did so, it caused the inner and the outer pane on the window of row 14 to fail and depart the aircraft, and this in turn caused a massive depressurization of the passenger cabin. So what is a depressurization then? Well, all aircraft that are designed to fly at higher altitudes have what we call pressurized cabins. This means that we take air, generally speaking from bleed air ducts from the engines, and we push it into the passenger cabin to try to maintain an air pressure inside of the cabin that is equal or just a little bit lower than what it is on the surface. That's because us humans, we cannot absorb oxygen through our lungs if the air pressure is too low. But this also means that there will be a huge difference in pressure from the outside of the aircraft to the inside of the aircraft. Generally, this is maintained by the pressure vessels, so all the aircraft body, passenger cabin that you're sitting inside, the cockpit, all the way back to the aft pressure bulkhead will maintain this pressure difference. And the difference can be as high as 8 pounds per square inch, PSI. But if there is a rupture to the pressure vessel, in this case by window number 14, well then the air pressure will try to equalize itself. This means that it will go from the high pressure inside of the pressure cabin to the low pressure outside. This will cause a lot of air to rush towards where the rupture is, and that might bring with it anything that is not strapped down during a few seconds while the pressure is equalizing. In this case, there was a female passenger seated next to the window of row 14, and as this depressurization happened and the air rushed towards the now broken window at row 14, she got pushed out by all of that air. Her arms and her upper body exited the aircraft, but fortunately she still had her seatbelt on, which meant that she was not pulled out completely. In the cockpit, this combination of an engine failure and a rapid depressurization caused some immediate problems. At time 11:03 and 33 seconds, you could hear on the cockpit voice recorder an increase in background noise. That's likely the engine failure, surge, and then the subsequent depressurization of the cabin. Following that, the flight data recorder indicates that the aircraft started an uncommanded bank towards the left, and also some severe vibrations. And those vibrations are likely coming from both the engine, which is now failing, but the fact that the engine is also breaking up means that there's going to be an increase of drag on the left-hand side. And that's likely also what's causing this sudden roll. 6 seconds later, the sound of the cabin altitude warning can be heard on the cockpit voice recorder. This means that the cabin altitude is now over 10,000 feet. And the reason that the cabin altitude warning goes off when we exceed 10,000 feet is because above 10,000 feet, the human body starts to have problems taking up oxygen. And we start to potentially experience signs of hypoxia. Because there is now a hole in the cabin, this cabin altitude is going to equalize with the outside pressure, which means that the cabin altitude will very soon become the same as the aircraft altitude. And that's an issue because they're still at 32,000 feet. And at 32,000 feet, the time of useful consciousness, that's in the time where we have kind of control over our muscles, body and mind, is going to be significantly shorter. That's why it's so important for you, if you are traveling as passengers, that if the oxygen masks fall down, you put them on and start breathing as soon as possible, because that will give you access to oxygen, which will stave off the effects of hypoxia. In the cockpit, this means that the pilots are now facing two very serious conditions at once. First, you have the engine failure and the controllability issues that that's causing with the uncommanded roll towards the left. Second of all, they have an indication of a rapid depressurization, which will require them to very quickly get their own oxygen masks on to make sure that they stay focused and to initiate communication. It's very important in a situation like this that the pilot flying continues to fly the aircraft, which is exactly what they did in this situation. The maximum roll recorded was about left-hand 41 degrees bank before the first officer took control back and roll the aircraft wings level. About 1 minute and 11 seconds after the failure, the first noises indicating that the crew is donning their oxygen masks can be heard on the cockpit voice recorder. At the same time, air traffic control is trying to contact the aircraft to give them further clearance, but the only thing that air traffic control can hear is static noises on the frequency. This is likely because when you put your oxygen mask on the 737, in order to communicate, especially on the older models on the NG fleet, you have to go down onto the audio control panel, which is on the center pedestal, and switch from the boom position to the mask position. When you do that, you can start to transmit from the mic that's inside of the mask. As soon as the captain gets her audio control panel sorted and she can start to communicate, she calls up air traffic control, which is New York Center at this time, and she tells them that Southwest 1380, we have an engine fire descending. This is then rapidly followed by her calling, we have single engine, we are descending, engine fire, engine number 1. Now, there's no indication in the final report that there was actually a fire warning going off. But there is always a possibility when a severe failure like this happens to an engine that you might get a momentarily spurious fire bell going off that could go for only a few seconds. Now, it's not shown in the final report that that was the case, but that could explain why the captain assumed that there was a fire they were having. Air traffic control comes back in and responds to this saying, where would you like to go, which airport, to which the captain responds, just give us a vector to your closest. At this point the aircraft is descending through 28,000 feet, and it should be pointed out that there hasn't been any PA made to the cabin crew about the emergency descent at this point. Generally, the first thing that the pilots have to do when they decide that an emergency descent is needed is to switch on to the PA and call out an emergency descent to the cabin crew. That's because we need them to be aware so they can sit down and put their masks on as well. But it's perfectly understandable that in a situation like this, where you have two severe failures that are affecting them at the same time, that some things will come out of order slightly. The most important thing here is that the crew have the aircraft under control and they have initiated the emergency descent to get down into breathable air. The crew is now starting to discuss where they want to go. They get a vector from air traffic control towards the closest geographical airport, which is Harrisburg. But they also need to descend, right? They're at 28,000 feet and it will take approximately 50 to 60 nautical miles to descend from 28,000 feet, even if you're doing an emergency descent. So the first officer is looking at his charts now, and he says that maybe we should go towards Philadelphia. Philadelphia is a good choice because it is a southwest destination, which means that they have support on the ground there. It is also a slightly bigger airport, which has better firefighting equipment, which could be a benefit if this would go much worse from the situation they're already in. The captain agrees that Philadelphia is probably the better destination to go towards, so they relayed that information to air traffic control. At time 11:05:32, the captain is heard asking the first officer if he has the aircraft under control. First officer responds that he does, and the captain then starts looking for the quick reference handbook to start going through the non-normal checklists that they have to cover. Now, it's quite tricky in a situation like this, even to know which checklist you want to start with, because generally speaking, we only deal with one failure at a time. And in this case, this crew is facing multiple failures and multiple serious failures. The captain decides to go for the engine fire, severe damage and separation non-normal checklist. And that's something that I fully and wholeheartedly agree with, because they could also go for the rapid depressurization and emergency descent, but they both know that the aircraft is descending, that they have their masks on and that they can communicate, which are the most important bits of that checklist. So even though they might have missed things, like for example talking to the cabin crew in this case, they know that the most important things are done. And she wants to go in to try to secure the engine, which I completely understand. Before the captain starts actually working through the checklist, she also reaches over, switches on the PA and makes a very quick PA telling the passengers and the crew that they're about to divert towards Philadelphia. Now this would be the first time that anyone in the back would have heard from the flight crew in this scenario. As the aircraft is descending now, the speed is kept about 280 to 300 knots. But those of you who have seen my video about how to do an emergency descent knows that the procedure calls for the speed to be increased towards the maximum structural speed of the aircraft, VMO or MMO, which is 340 knots or Mach 0.8182. But the crew has decided not to increase the speed, and that's because they're still feeling a lot of vibrations. And those vibrations could be indicative of structural issues with the aircraft. So to keep the speed lower, where the vibrations are still tolerable, is a very good call as well by the crew. Now, before the captain can actually start working through the non-normal checklist, she gets interrupted by the air traffic control, who asks them to confirm whether or not they are on fire and what the source of the fire is. Remember, up until this point, they haven't declared an official Mayday. The captain comes back to air traffic control and clarifies that no, we're actually not on fire. We have an engine failure on engine number 1 and we're single engine at the moment. This was then acknowledged by air traffic control, who clears them down to 11,000 feet, and they also ask them what kind of emergency equipment they need after landing, if any. Captain responds with, tell them to roll the trucks, and it's on the number 1 side, the captain's side. After this, they're handed over to the next air traffic controller, and when the captain checks in with the next air traffic controller, she also declares an official Mayday. It's worth pointing out here how important it is to actually get that official Mayday, Mayday, Mayday call in. Because when you do that, it is more likely that air traffic control is going to leave you alone to do your checklist, for example. In this transcript, the crew is being constantly interrupted throughout their descent down towards the airport by multiple frequency changes and several controllers asking them how much fuel they have on board, how many people they have on board, and so on. That's one of the things that stood out to me when I read this report, that should have possibly been better coordinated when it came to air traffic control side of it, because what you don't want as a pilot in a situation with many severe failures like this is to be constantly interrupted and having to re-explain the same information over and over again. At time 11:09:30, the captain decides that she wants to take control of the aircraft. It is actually standard operating procedures in Southwest Airlines that in case of a single engine situation, the captain should do the landing. So she takes the control from the first officer becomes pilot monitoring, and now the first officer starts executing the engine fire, serial damage and separation non-normal checklists. So what's going on in the back then, in the cabin? Well, after this quick message from my sponsor, I'll tell you all about it. I also want to take a few seconds here to say a special thank you to the sponsor of this episode, which is Skillshare. Now, I know that you are watching this because you are a curious person, a lifelong learner, someone who constantly wants to improve and understand the world around you better. And in that case, Skillshare is definitely something that you should be checking out. Okay, they have thousands of high-quality video courses and pretty much anything that you can imagine. A course that I'm using myself at the moment is 5 Minutes Creativity with Jasmine Cheyenne, where she gives kind of hands-on tips on how to chisel out a few minutes to be creative every single day. And it's something that I personally really need. But there are also courses in, storytelling, creative photography, or even how to use your own home simulator to improve and prepare before you start your private pilot license. So if you think, Peter, that sounds amazing. Well then, the 1,001st of you guys who clicks on this link here below will get 1 month of premium Skillshare absolutely for free. So click the link and start exploring your curiosity today. In the back of the cabin, when the depressurization happened, the oxygen masks fell down almost immediately. When the cabin crew saw that happened, they made their way back to their jump seat, sat down and put their own oxygen masks on, which they were instructed to do. They hadn't heard any call from the pilots initially, so when things had started to calm down a little bit, the cabin crew went and got themselves some portable oxygen bottles and started making their way down through the cabin to make sure that, if there was any injuries, and also to make sure that people have their masks on properly. When they got back to about the overwing exit around row 14, they saw to their horror that a female passenger had been pushed halfway out through the now open window. 2 of the cabin crew tried to pull her back into the cabin, but because of the enormous onflow of air, they just weren't strong enough to do so. 2 male passengers that were sitting in the close proximity volunteered to help out, and together they managed to pull the passenger back in and laid her down across the 3 seats next to row 14. The passenger was severely hurt at this point, so they started looking for people with medical experience. They found a paramedic and a nurse, and those 2 together started doing CPR on the passenger. But this also meant that the passengers that were seated in row 14 next to the hurt passenger, they had to move. And remember, this was a completely full flight, so there was no spare seats available. These passengers, they moved toward the back of the cabin and sat down on the crew jump seats instead. Back in the cockpit at time 11:10:14, the crew was handed over once again to the now Philadelphia approach controller. Philadelphia approach controller, again, asked the crew how many people they were on board, how much fuel they had left, and then they got descent clearance down to 6,000 feet. The crew now also started to get vectors to align them with final approach, and when the first officer realized this, he turned over to the captain and said, we're going to need a few minutes, right, to complete a few checklists? And the captain responded, nope, just keep going. This is actually a quite interesting conversation, because when pilots are being trained in the simulator, we always emphasize how important it is that all of the checklists are being completed before we go in and land. But of course, in reality, the pilots will have to take into consideration many things. And in this case, the captain is sitting in an aircraft where she can feel that it's severely vibrating. She can also feel that there's more drag than normal on her left-hand side. She doesn't know how badly damaged her aircraft is. So it is understandable here that the captain wants to get this aircraft down on the ground as quickly as possible. And it's also understandable that the first officer going back to his training, wants to complete the engine fire severe damage and separation checklist and the following one engine inoperative landing checklist, which he knows will take a little bit of time to do. But on this occasion, the captain is clearly prioritizing to get the aircraft down ahead of completing her checklist. This is a little bit risky on her behalf, because by not completing the checklist and rushing the aircraft in to get it on the ground, if something subsequently would go wrong before the landing, well then she is basically taking it upon her own responsibility that happens. But this is why it is so hard to be a commander of an aircraft, because you have to constantly weigh the pros and the cons against each other to see what is most important at any given time. At time 11:12:28, the first officer looks up on his pressurization panel and realizes that the cabin is now below 10,000 feet. This is where it's considered safe for them to remove their oxygen masks. So he removes his own oxygen masks, he initiates communication again with the captain, and where the captain hands the controls back to the first officer for a few seconds while she removes her own oxygen masks and then resumes control again. Air traffic control now clears the aircraft to descend further to 4,000 feet, and here again the first officer indicates to the captain that he thinks that they need a little bit more time to complete their checklists. The crew asks air traffic control if they can get a very long final, about 20 to 25 miles, but the captain also indicates, as she's talking to air traffic control, that she might ask for a shorter final later on. As they're descending now, the first officer suggests to the captain that they should talk to the cabin crew. The captain agrees that's a good idea, but she's handling the aircraft at the moment, so she delegates that to the first officer. I just want to point out here that I think that the first officer is doing a great job here. Right? Reading this accident report, he is assertive, he comes with good suggestions all the time, and they're very pertinent, good, smart suggestions. The first officer now calls the cabin crew, and initially there's no response back. One of the cabin crew later explained that she heard the ding from the cockpit. She lifted up the interphone, but because of the extreme noise in the cabin, she couldn't hear what was being said. A few seconds later, the cabin crew called the cockpit back up again, and the first officer received a report of what was going on in the cabin. And this is now the first time that they hear about the damage to the window on row 14 and also about the severely injured passenger. When the first officer is done talking to the cabin crew, he reports to the captain, tells her about the passenger and the status in the back, and this just reinforces the captain's will to get this aircraft down on the ground. But there are still checklist items that needs to be done. Most of the engine fire, severe damage and separation checklist has been completed. The one engine inoperative landing checklist has not been completed. But here the captain asks to get vectors in for a shorter final, and she also decides that she wants to land with flaps 5 instead of the normal flaps 15 landing you do after an engine failure. The reason that she wants to do this is because she feels that the aircraft is not handling normally. And she's afraid that if the speed comes back too far, she might lose control of the aircraft. Once again, she does not know how her wing looks. It could be severely damaged. The transcripts from the cockpit voice recorder indicate that the first officer is not 100% happy with this. He says a few times that maybe we should go for flaps 15 instead, maybe we should do something with no, kind of alluding to the fact that they have been practicing to do single engine flap 15 landings in the simulator, while they haven't done that with flaps 5. But of course, captain is the captain, and the captain is also the one handling and feeling the aircraft. So eventually he settles down on the flaps 5 and the flaps 5 speed, which is around 180 knots. They're getting vectors in for runway 27 left in Philadelphia, and they decided that they're going to do a visual approach rather than an ILS approach. Surface wind in Philadelphia is 280 degrees 19, gusting 25, so it's quite windy but more or less straight down the runway. The crew selects flaps 1 and then flaps 5 and then turn on to final. Now here is where they should be doing the one engine inoperative deferred item landing checklist, which have some additional items to it, but instead they go for the normal landing checklist, which will still safeguard that they have the gear down and the flaps and the speed brake armed and so on. But because they're doing a visual approach, they're ending up quite low. So during a large part of the approach, they're getting glide slope, and even
too low terrain, GPWS
warnings. but they're fully visual. They can see the runway, they can see the poppies, so it's unlikely that this would pose any real risk to the aircraft. Behind the cockpit, in the cabin, there are some other problems at this point, because the cabin crew has been made aware by the first officer that they're about to land in about 5 minutes. This means that they've had time to prepare the passengers for an emergency landing. But the injured passenger is still lying down across row 14. This has forced the passengers that were sitting there, remember, to go back and sit on the crew jump seat. But that also means that there's nowhere for the crew who's supposed to sit there to actually sit. This causes the cabin crew to actually sit down on the floor, being held down and secured by passengers at about 10 seconds prior to landing, which is when they start shouting, "Heads down, stay down," which is a standard call in case of an emergency landing. At time 11:20 and 33, Southwest Airlines Flight 1380 lands safely on runway 27 left in Philadelphia. They taxi off on a high-speed taxiway and they come to stop on the parallel taxiway to the runway, where they get into contact with air traffic control, with the fire chief, who comes up and inspects the aircraft. They shut the aircraft down and the fire chief tells the crew that they will be sending out buses and that paramedics is going to come on board and take care of the severely injured passenger. The crew performs the shutdown checklist, and crucially, they also remembered to pull the CVR, the cockpit voice recorder circuit breaker, to make sure that all of the things that I've now told you is being saved for the subsequent investigation. The captain then goes out and helps the crew to coordinate the disembarkation of both the injured passenger and the rest of the passengers. The investigation into this incident showed that the crew's decision to skip certain checklist points in order to get the aircraft down on the ground was justified given the circumstances. The investigation team also quickly pinpointed that it was the number 13 fan blade that had detached, and that it had detached in the 6 o'clock position. And the fact that it had done so had caused much more damage through that shockwave than was anticipated during testing. This led to the authorities mandating a redesign of the CFM56 cowling and the way that the containment ring was made, but also that all fan blades that were connected to CFM56 engines had to be re-evaluated carefully and checked for fatigue cracking in the dovetail part of the fan blade before they could continue to operate. When it came to the cabin crew, there was also recommendations that they needed to be further trained and instructed in the fact that it was really, really important that they were seated in their jump seats during an emergency landing, not only for their own safety, but also in case that emergency landing led to an emergency evacuation, they had to be there in order to be able to open the doors. All in all, it was found that this accident was handled very well by both the pilots, the cabin crew, but also the passengers who were helping out during the incident. Sadly, the injured female passenger passed away from the injuries that she sustained as she was outside of the window, making her the first fatality in commercial aviation in America for over 9 years up until that point. Now, if you want to see an absolutely crazy story where a captain was actually sucked out of the cockpit window during flight, then check out the video up here. If you want to support the channel, consider becoming part of my Patreon crew or buy yourself a t-shirt. I have quite a few of them. Have an absolutely fantastic day and I'll see you next time. Bye-bye.